All right, welcome to lesson 1 for chapter 6. Chapter 6, we're going to do a really quick review of ecology. So to start us off with that, in this lesson, we're going to focus on biotic and abiotic factors and then the differences between those two. So learning goal is that you should be able to differentiate and describe the differences between biotic and abiotic factors, along with their roles in ecosystems. So success criteria. By the end of this lesson, you should be able to differentiate biotic and abiotic ecological factors in an animal's habitat, describe how energy is used by a heterotroph or an autotroph, and then contrast the survival strategies of endotherms and ectotherms when environmental conditions become unfavorable and food resources become scarce. So ectotherms, endotherms, that's how they're getting heat from the environment. Some animals can create it themselves, some need it from the sun. All right, so first let's define ecology, if this is our chapter on ecology. So ecology is the study of relationships of organisms to their environment and to other organisms. So it's how everything interacts. So animals and their abiotic environment, biotic factors are living factors. So animals are going to be living factors. Plants are going to be living factors. Abiotic means it's not living. So it's the non-living things around it. So habitat is all of the living, biotic, and non-living, abiotic characteristics of an area in which the animal lives. So this is where this deer lives. The abiotic is the snow, the water around it. The biotic is the plants and the other organisms. Tolerance range is a range of values for any abiotic factor that is compatible with life for an animal. And that sounds really funky, but basically it's like temperature. Temperature is an abiotic factor. It's not a living thing, but it's the range of temperature that is compatible with life. There is such a thing as too cold for anything to live and such a thing for too hot for anything to live. And every animal in between is going to have a range of tolerance of what it can handle. And then within that range of tolerance, there's also a range of optimum. And this is the range of values that defines the conditions under which the animal is the most successful. This is optimal, prime. This is where it wants to be. Population will grow, be happy, will have food. That is the range of optimum. Then we have our limiting factors. So this is any one of the combination of abiotic factors that is outside of the tolerance range for that factor. So it's limiting growth because it is outside the range of tolerance. So the temperature, the climate could be a limiting factor if it is restricting population growth. And then taxis is the orientation of an animal with respect to an abiotic factor. So its relationship with that. So this is an example of range of tolerance. So this is just a really vague table. There's nothing specifically graphed. It's just to show the idea. So any environmental factor could go here. It could be temperature. It could be pH. It could be humidity, how much water, and then success is over here. So low success meaning they're not living very well at all, and high success being they are reproducing and happy. So this is the lower limit of tolerance. This is the upper limit of tolerance. And then the optimum range is going to be in the center there where we see the highest part of that bell curve. All right, so let's look at energy. Energy comes from living, can come from living things, but energy itself is not living. So heterotrophic, what does that mean? Heterotrophic organisms are organisms that supply energy needs by ingesting other organisms. They cannot photosynthesize. They're not staring at the sun and just taking the energy in. They are eating other things to get that energy. We are heterotrophs. All animals are heterotrophs. Autotrophs, hopefully you remember this from last semester, but autotroph are organisms that carry on photosynthesis or other carbon-fixing activities to supply food. They create food within themselves using that carbon-fixing activity. Examples are plants, algae, and some protists. And the energy budget is an accounting of an animal's total energy intake and a description of how the energy is used and lost. So if this deer is eating that grass, where is that energy going? And we can kind of see this here. So there's assimilation. So this is existence energy. This is what the energy is used for just to exist. Pumping blood, gas exchange, muscle contraction, repair processes, just living. Then there's also productive energy. So growth, mating, and caring for young. And then loss is going to be excretory energy. So feces and excretion, and also loss of heat. All right, so temperature, abiotic factor, but it does influence the rates of chemical reactions in animals. So it does greatly affect how animals live. So heat loss would be infrared and heat radiation to surroundings. We are warm creatures. Even if you run cold, you are giving off heat, and that is a breakdown of energy. And this is convection to air and then evaporative heat. For heat gain, we have solar radiation. So we gain heat from solar radiation hitting us or the environment. And then infrared or heat radiation from surroundings. So someone else could warm you up with their heat that they're giving off. And then also metabolic activity. This is relatively inefficient for gaining heat, but breaking things down. Okay, so what happens when body temperature or resources are scarce? Well, body temperature goes down because resources are scarce or because the environment is cooling off. We have decreased metabolism when this happens, and there's 4 different things that can happen. So first is torpor, and this is decreased metabolism and lowered body temperature, briefly daily period. So this isn't like long term, it's brief over like daily. So examples of animals that do this are bats and hummingbirds. So this is a bat in torpor. They have, like hummingbirds, like they have a lot of energy going on, and so they have to have those rest periods and decrease the metabolism to give their body a break. There's also hibernation, which you've probably heard of. And hibernation is decreased metabolism and lowered body temperature for weeks or months. The hibernator's thermostat drops to about 2 degrees Celsius, and rodents, shrews, and bats do this. So it's like a long sleep. Speaking of long sleep, there is one animal that also does a winter sleep, and this is for weeks or months, and the animal is easily aroused. It's not hibernation, it's not like locked in. They can wake up really easily. But if they're not woken up, they will sleep for a long time. And the body temperature drops, but it's less than in hibernation, and black bears are those who do this. All right, one that you most likely have not heard of is aestivation, and this is a period of inactivity through extended periods of drying, usually within burrows. So the animals that can do this are some invertebrates, reptiles, amphibians, and lungfish. So these are some snails going through aestivation. So it's a dry period. They're just chilling. They're waiting for their time to shine again when it is less dry. All right, and some other specific abiotic factors that may not have been mentioned are moisture. So when there is water loss must be replaced. So water going through an ecosystem, that is an abiotic factor. Light determines the daily activities or the timing of daily activities. There's sensors in our brains that really decide like when we get tired, when we go to sleep. All of that is based on light. And then geology and soils. So texture, organic matter, water content. I usually, if you've heard me talk about soils, I will say that soil is alive and dirt is dead. Part of the components of soil is living organisms. So I won't normally say soil itself is under abiotic factors, but the dirt without the living things in it that makes up soil are abiotic factors. All right, if you have any questions, please let me know. We will continue talking about ecology throughout this chapter, get on to some more specific topics. If you have any questions, let me know, and I will see you in the next one.